Let's check today's weather. Cloudy, sunny, maybe a bit of rain. Pretty ordinary, right? But what if we left Earth and checked the weather on other planets in our solar system? Take Mars, for example. It actually has seasons like Earth. It has wind. It even gets snow. But on Mars, it's not just a light breeze. It's massive dust storms that can cover the entire planet, lasting for months at a time. How about Venus? The weather there is straight up hellish. Thick clouds of sulfuric acid with constant lightning, and temperatures soaring over 400 degrees Celsius. Forget your umbrella, you'd need a spacesuit. Actually, even a spacesuit wouldn't be enough to survive. And then there's giant Jupiter. It has storms bigger than Earth itself, raging non-stop for centuries. At that point, the whole planet is basically one giant nightmare. Today, let's dive into the wildest, most extreme weather you'll find on the planets of our solar system. Mercury has the biggest temperature swing in the entire solar system. The difference between day and night? About 600 degrees Celsius. Mercury is the closest planet to the Sun, and it barely has any atmosphere at all. An atmosphere helps distribute heat, circulating it around the planet, and it can store heat during the day and release it at night to prevent temperatures from crashing. But Mercury's atmosphere is so thin, it basically doesn't exist. That means it can't hold on to any heat. As a result, the temperature swings are extreme. On top of that, Mercury rotates incredibly slowly. One full rotation takes about 58.6 Earth days. Meanwhile, it orbits the Sun every 88 days. Because of this, a solar day on Mercury, from one sunrise to the next, lasts about 176 Earth days. It's also really close to the Sun, so daytime temperatures can soar to around 430 degrees Celsius, hot enough to melt lead. But when the long day ends and night falls, temperatures plunge to minus 180 degrees Celsius. That's one of the most extreme temperature differences you can imagine. Picture standing on Mercury during the day. There are no clouds, no air. The sunlight just blasts the surface directly. It's like cranking an oven to its highest setting and stepping inside. Even a spacesuit would just burn up. And the sky? It wouldn't be blue like on Earth. Even during the day, it would look pitch black because there's no atmosphere to scatter the light. Now imagine sunset on Mercury. As soon as the sun dips below the horizon, the ground loses its heat almost instantly. The surface goes from blazing hot to deep freeze levels in just a few hours. Actually, freezer doesn't even cut it. It's way colder. So here's a question. Does Mercury even have weather? Technically, not really. No rain, no wind, no snow. Just brutally hot when the sun is up, and unimaginably cold when it's gone. Do you know which planet is the hottest in the solar system? You might guess Mercury, since it's closest to the Sun, but the real answer is Venus. Venus is the hottest planet in the solar system. It has the highest surface pressure, and its weather is downright insane. It's no exaggeration to call it hell in space. Venus is the second planet from the Sun, but it's hotter than Mercury for one big reason: its massive atmosphere. Venus's atmosphere is almost entirely carbon dioxide, creating an extreme greenhouse effect. On Earth, the greenhouse effect warms the planet, but on Venus it's so strong that it turns the whole world into a giant pressure cooker. The heat from the sun gets trapped and can't escape, causing temperatures to skyrocket. And while most planets have big differences between day and night temperatures, Venus doesn't. Day or night, it's the same, around 475 degrees Celsius all the time. Just relentless, hellish heat. The surface pressure is also insane, about 92 times Earth's. That's like being a kilometer underwater here. Venus's thick CO2 atmosphere is so heavy that it's compressed by gravity into this extreme pressure. Normal spacesuits or landers can't handle it. They'd just get crushed. That's why the Soviet Venera 13 lander in the early 1980s managed to survive for only about 2 hours on the surface. And the skies of Venus? Totally alien. They're filled with thick clouds of sulfuric acid. These clouds even produce sulfuric acid rain. But here's the wild part. That acid rain never reaches the surface. Venus's surface temperature is about 475 degrees Celsius, way above sulfuric acid's boiling point of 337 degrees Celsius. So, as the rain falls, it evaporates completely before it can hit the ground, disappearing around 30 kilometers up. The vapor then rises again to form new clouds, creating a constant cycle. Now let's talk about the wind. Near the surface, winds are only around 3 to 5 kilometers per hour, which on Earth would be a gentle breeze. But on Venus, with 92 times Earth's pressure, even that slow wind packs a punch. It hits with the force of hurricane-level winds on Earth, around 200 kilometers per hour. In 2024, Hurricane Milton hit Florida with winds around 250 kilometers per hour, or 155 miles per hour. At that speed, you can't even walk outside. Trees fall and roofs get ripped off. On Venus, winds this strong happen all the time. And it gets even more extreme higher up. At around 30 kilometers altitude, winds blow at 50 to 100 kilometers per hour, go up past 50 kilometers, and whine scream at over 360 kilometers per hour. It's a planet of truly monstrous winds and heat. After Earth, which planet seems like the best candidate for humans to live on? Mars. A lot of people talk about humans colonizing Mars someday. But the question is, when will that actually be possible? Mars is interesting because it has seasons like Earth, it has wind, it even gets snow. But don't be fooled. Compared to Earth, it's an incredibly harsh, unforgiving environment. In winter, temperatures can drop below minus 100 degrees Celsius. The air is so thin you couldn't breathe, and giant dust storms can blanket the entire planet, bigger than any hurricane on Earth. So, what's Mars's weather really like? First, the average temperature. Mars is much farther from the sun than Earth, so it averages about minus 60 degrees Celsius. During the day, in the mid-latitudes, it can warm up to around 0 degrees Celsius. Near the equator, it can even hit 20 degrees Celsius on some days. Sounds not too bad, right? But at night, it can drop below minus 100 degrees Celsius. So daytime is like a chilly autumn on Earth, but nighttime is colder than Antarctica. Mars's atmosphere is only about 1% as thick as Earth's. That means there's almost no air. What little atmosphere it has is mostly carbon dioxide. With such a thin atmosphere, a few things happen. First, you can't breathe. Without a spacesuit, you'd suffocate in seconds. Second, the atmosphere can't hold on to heat, so it heats up quickly during the day, then freezes rapidly at night. Here's something interesting. Mars has seasons, just like Earth. That's because its axis is tilted about 25.2 degrees, very similar to Earth's 23.5 degrees. This tilt means different regions get different amounts of sunlight over the year. But Mars's year is longer, about 687 Earth days. So each Martian season lasts nearly twice as long as on Earth. Even with its thin atmosphere, Mars is famous for its dust storms. On Earth, we get hurricanes and typhoons, but Mars's dust storms are on another level. They can cover the entire planet. And once they start, they can last for months. Wind speeds can reach around 160 kilometers per hour, similar to strong hurricanes on Earth. But here's the catch. With only 1% of Earth's air pressure, even fast winds feel more like a gentle breeze. So they wouldn't knock over a lander like in the Martian movie. The real problem isn't the wind itself, it's the dust. Martian dust particles are super fine, and they can stay suspended in the air for a long time. That's why once a dust storm kicks up, it can block sunlight for months. In 2018, NASA's Opportunity rover was caught in one of these planet-wide storms, couldn't recharge its batteries, and went silent forever. Now for one of the coolest parts about Martian weather, snow. But not the kind of snow we know. Mars can have carbon dioxide snow. In the polar regions, especially the South Pole in winter, temperatures drop below minus 125 degrees Celsius. At that point, carbon dioxide gas actually freezes, so you get dry ice snow falling from the sky. NASA's landers have even detected this phenomenon. But don't imagine big fluffy flakes. Mars's atmosphere is so thin that the snow falls slowly as tiny, delicate particles. In 2008, NASA's Phoenix lander actually watched these fine CO2 snowflakes drifting down. Jupiter is the largest planet in our solar system. On Jupiter, storms rage with winds over 300 kilometers per hour. Its lightning is up to 100 times more powerful than Earth's, and there's a giant hurricane that's been spinning for centuries. Unlike the rocky planets we've talked about before, Jupiter, along with Saturn, Uranus, and Neptune, is a gas giant. That means there's no solid surface, just massive, deep layers of hydrogen and helium gas. If you tried to land on Jupiter, you'd just keep falling, sinking deeper and deeper until the pressure crushed you. So what's Jupiter's weather like? It's a planet of extreme, violent storms and fierce winds. When you look at Jupiter, the first thing you'll probably notice is that huge, swirling red spot. That's the famous Great Red Spot, a massive storm larger than Earth itself, spinning for over 350 years non-stop. For comparison, Earth's most powerful hurricanes have wind speeds around 300 kilometers per hour. The Great Red Spot? Average winds hit 600 kilometers per hour. And it's not just that one spot. Jupiter is covered with bands of powerful winds and chaotic turbulence all around the planet. But it's not just the winds. Jupiter also has terrifying lightning. Its lightning bolts are up to 100 times more energetic than Earth's, and more than 10 times bigger. Observations show that lightning on Jupiter is especially active near its polar regions. In 2020, NASA's Juno spacecraft discovered something even stranger: shallow lightning. Unlike typical Earth lightning, these bolts form high in Jupiter's atmosphere. Here's how scientists think it works. Powerful convection lifts water ice, vapor, and ammonia high up. There, ammonia and water combine into slushy ice crystals. These icy particles collide, creating static electricity that discharges as lightning. And there's more. These collisions can produce strange ammonia-water mush balls, like slushy hailstones. They fall through the atmosphere like rain, helping create and sustain these unique lightning storms. So on Jupiter, you don't just get lightning. You get bizarre ammonia-rich rain falling through the most intense storms in the solar system. Saturn, probably the most strikingly beautiful planet in the solar system. Its massive, shimmering rings make it instantly recognizable. But behind that gorgeous appearance lies some of the strangest, most mysterious weather in the solar system. Imagine this: a giant hexagon-shaped storm, winds blasting at 1,800 kilometers per hour, massive lightning, and even rain made of diamonds. So what's the weather like on Saturn? Like Jupiter, Saturn is a gas giant. It doesn't have a solid surface like Earth. Instead, it's made mostly of hydrogen and helium. And the atmosphere? It produces absolutely wild weather. For comparison, the fastest tornadoes on Earth have reached nearly 500 kilometers per hour. But Saturn's winds can scream at an unbelievable 1,800 kilometers per hour. But Saturn's most famous weather phenomenon is its mysterious hexagon storm. While most storms spin in circles, Saturn's North Pole features a massive, perfectly shaped hexagon. This thing is so huge it's more than twice the diameter of Earth. Scientists still don't fully understand how such a precise shape can form naturally. It remains one of the planet's biggest mysteries. And it's not just the winds and strange shapes. Saturn is home to the most powerful lightning in the solar system. Its lightning can be up to 10,000 times more powerful than on Earth. These lightning storms can last for weeks, and a single lightning bolt can illuminate thousands of kilometers. Now here's the truly mind-blowing part. Saturn may have diamond rain. On Earth, water evaporates, forms clouds, and falls as rain. But on Saturn, the atmosphere is mostly hydrogen and helium, but it also contains methane. When Saturn's intense lightning strikes, it breaks apart methane molecules, freeing carbon atoms. These carbon atoms clump together into tiny bits of graphite. As these bits sink deeper into Saturn's atmosphere, the pressure and temperature increase dramatically. This transforms the graphite into diamonds. Essentially, diamond chunks rain down through Saturn's atmosphere. Scientists estimate that Saturn could produce around 1,000 tons of diamond rain every year. And it's not just Saturn. Researchers think this incredible diamond rain could also happen on Jupiter, Uranus, and Neptune. In fact, in the deep interiors of Uranus and Neptune, the diamonds might be even bigger. Uranus is the planet with the strangest seasons in the entire solar system. It basically rolls around the sun on its side, with one day lasting 17 hours, and each season lasting a whopping 42 years. It's a world of ultra-fast winds, massive icy storms, and even diamond rain. Most planets have a slight axial tilt, but Uranus is completely tipped over. Earth's axis is tilted about 23.5 degrees. Uranus? A wild 98 degrees. It's practically lying on its side as it orbits. It takes Uranus 84 Earth years to go around the Sun once. That means each season lasts 42 Earth years. So one hemisphere can face the Sun continuously for 42 years, while the other sits in complete darkness for 42 years straight. Now let's talk about the weather. Winds on Uranus can hit 900 kilometers per hour. That's fast enough to rip buildings apart and evaporate oceans if it happened on Earth. Temperatures? The average is a frigid minus 224 degrees Celsius, making it the coldest planet in the solar system. Even on this icy world, there are giant storms as big as Earth itself that can last for months. These storms whip up massive clouds of icy dust and methane, wrapping the planet in swirling chaos. And here's one of the most amazing things. Uranus likely has diamond rain. Its atmosphere is full of methane. As methane sinks deeper into the planet, it's exposed to immense pressure and heat. That breaks the methane apart, freeing carbon atoms. These carbon atoms bond into graphite and then transform into diamonds as they're compressed. Scientists think these diamonds don't just stay tiny. They could grow to dozens of centimeters across. Some might even reach the size of a bowling ball as they fall like rain through the planet's deep layers. Neptune is the outermost planet in our solar system. It's known for having the fastest winds in the solar system, massive storms, gigantic vortices, and powerful lightning. Neptune is about 4.5 billion kilometers away from the Sun, Sunlight takes about 4.5 hours to reach it. That's why Neptune's average temperature is a frigid -214 degrees Celsius, making it the second coldest planet in the solar system. It also has the fastest, most intense winds we know of, reaching speeds of up to 2,400 kilometers per hour. Remember Jupiter's Great Red Spot? That giant storm? Well, Neptune has something similar called the Great Dark Spot. It's a massive swirling storm about the size of Earth. Unlike Jupiter's red spot, which has lasted for at least 350 years, Neptune's great dark spots appear and disappear in just a few years and often reform in other locations. This tells us Neptune's weather is much more unpredictable. Neptune also experiences incredible lightning storms. These bolts are far more powerful than those on Earth and can stretch for hundreds of kilometers. They typically form inside Neptune's violent storms. And finally, you might already know that it actually rains diamonds on Neptune. Pluto, the coldest planet in the solar system? Wait, Pluto's not even officially a planet anymore, right? That's true. Since 2006, it's been classified as a dwarf planet. But let's be honest, it wouldn't feel right leaving Pluto out. It's one of the most extreme places you can imagine, experiencing brutal, freezing cold, incredibly thin atmosphere, and even snow made of frozen nitrogen. Pluto is, on average, about 5.9 billion kilometers from the Sun. Sunlight takes over 5 hours just to get there. That far from the Sun, Pluto's average temperature is a bone-chilling -230 degrees Celsius. Its orbit is highly elliptical. Sometimes it's as close as 4.4 billion kilometers. Other times it swings out to 7.4 billion kilometers. Pluto does have an atmosphere, but it's temporary. It's made mainly of nitrogen, methane, and carbon monoxide. When Pluto gets closer to the Sun, its surface ice warms up and turns into gas, forming a thin, temporary atmosphere. But when it moves farther away, that atmosphere freezes and falls back to the ground, disappearing entirely in winter. Speaking of seasons, how long is a year on Pluto? A single orbit takes 248 Earth years. That means Pluto's seasons are incredibly long. Summer lasts about 62 Earth years, and so does winter. And yes, Pluto gets snow, but not the water ice snow we know on Earth. It's snow made of frozen nitrogen. The surface is covered in nitrogen and methane ice, with towering icy mountains reaching up to 3,500 meters. Interestingly, those mountains are made of water ice. On Pluto, water ice behaves like rock, forming solid, rugged peaks. Nitrogen and methane ices are too soft to build such tall mountains. Instead, water ice acts as the bedrock of this frigid, alien world. Across our solar system, there are weather phenomena more extreme than we could ever imagine. But if you think about it, the most incredible climate in the entire solar system is right here on Earth. The weather on this planet, our home, is truly miraculous and unique. It's something worth appreciating every single day.